Hi, second year students. Exercise 4.1, the remaining questions. Ordinary differential equation. Ordinary differential equations are mentioned and their corresponding solution is also mentioned. We are asked to verify. How to verify? Differentiate one time, plug in here. Differentiate one time, put the value here, and so on. And so on. These are later matter to discuss and to verify. Ordinary differential equations, their solution is given to us. Just differentiate according to requirement and put the value, and it is going to work wonder. Question number 3, part number 1. Part number 1. We are asked 2y dash plus y is equal to 0 has a solution function that's y is equal to e raised minus x over 2. If we inspect the situation, we need first derivative. We need first derivative of the function and put here to verify that if both sides are equal, then it is a solution, otherwise not. Differentiate one times dy over dx. Differentiation of exponential function is same. Multiply with the derivative of the power. It is minus x over 2. Its differentiation is minus 1 over 2. Writing in a good fashion, first symbol, then constant, the latter is the place for variables. It seems good. Okay, put here 2y dash or dy upon dx, they are interchangeable, they are same. We are familiar from this terminology. What is value of first derivative? It is. What is value of y? It is given to us. Put both values. If both sides are equal, it's our solution. Otherwise not. 2 times dy upon dx means minus 1 over 2 e raised minus x over 2 plus value of y is itself e raised minus x over 2 is equal to 0. 2 cancel out. What remains? Minus e raised minus x over 2 plus e raised minus x over 2 plus 2. Both terms are identical but differ in symbol. It's negative, it's positive, cancel out. 0 is equal to 0. Yes, this y is equal to e raised x minus 2 is a solution of this one. Verified, proved. Similarly, taking the second one, same. The requirement is first derivative. Put here value of y itself here, and both sides must be equal in that case. Let me erase this. I have a little space today as there are humongous questions, huge questions like clouds of monsoon, and they have given a little space free. Okay. Second y is given by, let me demarcate a line. Now here is solution. Y is equal to e raised 3x plus 10 times e raised 2x, and our requirement is single derivative. Differentiation of e exponential function is same, e raised 3x as it is. Differentiation of the power, that is 3 times 1. Differentiation of 3x is 3 times 1 plus 10 times e raised 2x, same. Differentiation of the power, 2 times 1. Writing in a good fashion, first constant, then 3 times e raised 3x plus 2 times the 20 e raised to x. That's my value of dy upon dx. So we have to put in that, putting in the value, putting values in the given differential equation, that is dy over dx minus 2y is equal to e raised 3x. Okay, dy upon dx is equal to this one, 3 times e raised 3x plus 20 e raised 2x minus 2. Value of y, it's equal to e raised 3. Value of y is e raised 3x plus 10 times e raised 2x, e raised 2x, bracket over, that's equal to e raised 3x. Multiplying this minus 2 throughout, I am going to have something like 3 times e raised 3x plus 20 e raised 2x minus 2 times e raised 3x minus plus minus 20 times e raised 2x. It must be equal to e raised 3x if it is a solution. Now it's negative, positive, it's negative, cancelled out. 3 e raised 3x minus 2, whatever remains, let me write down to give you good view. Let me check I am in the frame or not. Okay, I am running out of the frame. Whatever remains, I am writing here 3 times e raised 3x minus 2 times e raised 3x, it is equal to e raised 3x. Let me check. Good. Now, the difference of these two leads to e raised 3x is equal to e raised 3x. It's our verification proved. Yes, it's a solution. Yes, it's a solution. Moving towards question number 2. Solution is based on trigonometric function. That's 10. Okay. Now y is equal to 5 times 10 5x. 5 times 10 5x is the solution of single derivative is equal to 25 plus y square plus y square. Okay. Here equation is y dash single derivative plus y square. This prime shows first derivative. A single prime shows single derivative, double prime shows double derivative, second derivative, and so on. 25. What is y? Y is given to us. Y is equal to 5 times 10 5x. 5 times 10 5x. According to requirement, differentiate first time, one time only. dy over dx. It can also be written as y prime. 5 times differentiation of 10 is sec square. Whatever the argument writes in, then differentiation of the argument as it is not simple. Simple means it must be only x, theta or y. It's 5 times x, 5 times x. Differentiation of 5x is 5 times 1. It will become 5 5 the 25 times sec square 5x. That's the value of our single derivative, our first derivative. Putting the values in that equation, what we are going to get, let's see. This is y dash 25 plus y square. Y dash means 25 times sec square 5x is equal to 25 remains same on is equal to, yes, 25 plus y square. Okay, I am continuing left hand side. 25, simple identity from trigonometry. Sec square is equal to 1 plus tan square, keeping the argument angle same. It's equal to 25 plus y square as we are required to prove. Multiply 25, it will become 25 times tan square 5x is equal to 25 plus y square. As I am running out of the frame, I am writing this step here. 25 plus 25, instead of 25 let me write 5 times tan 5x overall square is equal to 25 plus y square. If we have a look at this one, what the solution is given to us, y is equal to 5 tan 5x. It is the value of y. It is the value of, instead of 5 tan 5x, I write here y having square. I am going to get left hand side is equal to right hand side as demanded. Yes, it's a proof. Or one can put value of y here, and you will get both sides equal in that case. You can put value of y also here. I have pursued the left hand side. left hand side, and I have shown it is equal to right hand side. Okay. Next question is a sort of lengthy, a bit sort of lengthy. Okay, what should I do? What should I do in that case? Let me solve this first, then moving there. Okay, let me continue where I am heading. I can manage these questions. Y dash, we have to prove y dash plus y is equal to sin x when y is given to us, y is half sin x, negative half cos x plus 10 times e raised minus x plus 10 times e raised minus x. Yes, differentiating one time as the requirement of the question. Y prime means single digit of 1 upon 2. Differentiation of sine is cos 1 upon 2. Differentiation of cos is negative sine plus 10 e raised minus x. Same. Differentiation of the power is minus 1. We are going to get something y dash is equal to 1 upon 2 cos x minus plus 1 upon 2 sin x negative positive negative 10 raised e minus x. This is the value of y dash. This is the value of y dash. Single derivative put here as well as value of y. You are going to get both sides equal. Let me check the frame. Yes, I have limited space. Y dash plus y is equal to sin x. Mine y dash is half cos x plus half sin x negative 10 times e raised minus x. That's my value of y dash. That's my value of y dash plus value of y itself the function, that is 1 over 2 half sine negative half cos x plus 10 times e raised minus x. E raised minus. Okay, have a look. Negative positive cancel out, as well as this cos cancel out. Half sine and half sine remains. Half sine and half sine remains. 1 upon 2 sin x plus 1 upon 2 sin x. Half sine, it's equal to full sine. 1 sin x, as it is equal to right hand side. We have proved the validity of this function to be the solution of this differential equation. Moving towards question number 5, a bit tricky. In that case, we have given separated differentials dy and dx. We have to manage them as dy over dx to show that its solution is this one. We have to manage the ratio of dy over dx. Okay, let me erase this first. Question number 5. Now the length of the question is kept on shrinking. In that case, fifth, we have x cube times differential dy 2 times dx is equal to 0. Then the solution is given to us, y is equal to negative 1 over x square in addition 6. Okay, this one. I can write this as dy shift 2 dx on the right hand side, 2 times dx. We are interested in the ratio dy over dx, shift dx here, x cube dy over dx is equal to 2. X cube dy over dx is equal to 2. X cube dy over dx is equal to 2. Differentiate this equation one time, dy over dx. Prior to differentiating this one, minus 1 over x square, The elementary learner or beginner apply quotient formula on this. It is not incorrect, it's also correct, but it is cumbersome. It's going to take time, consume your energy, exhaust you. Just write y in that fashion minus. Switch this to numerator. It can be written as 1 over x square minus x square raised minus 2. This positive 2 will become negative 2 in numerator plus 6. Now differentiate. It's simple one. Y dash. Make the power coefficient minus already present. What is the power? That's minus 2. Subtract 1 from the power, it will become minus 3. Differentiate of a constant is 0. Minus minus plus y dash 2 times x raised minus 3. Turn the exponent positive. Again shift in denominator 2 over x cube. 2 over x cube. That's the value to be inserted here. Mark my words. dy over dx or y dash, they are equal. They are same. Means I have x cube. Instead of dy over dx, y dash means dy over dx. Y dash means dy over dx. It is value of dy over dx. It means 2 over x cube is equal to 2. Cancelled out. 2 is equal to as the required solution, and we have proved in that case. The final part of question number 3 of verification, that is y dash minus 1 over x times y is equal to 1, and here we have given y is equal to x ln x, and the good restriction x is greater than 0, even it must be x is greater than 1, because if log is 1 it is meaningless. Log should be greater than 1, but it has value greater than 0 has value. It's a good restriction in that case. Question number 6 part of question number 3. I have, let me take y and differentiate x times ln x. Applying product rule on this, there are two functions, they are multiplication product rule. Product rule y dash r dy upon dx same. Y dash, right, first same. Differentiation of ln x is 1 over x plus second function same ln x, differentiation of x is 1. Cancelled out. We are going to get 1 plus ln x, the sum of 1 and ln x. The sum of 1 and ln x to be inserted here. That is y dash minus 1 over x times y is equal to 1. Let's see. Y dash means 1 plus ln x. Okay, minus 1 over x. What is y? Mind y is x ln x. X ln x, it's equal to 1. X cancel out. What remains? 1 plus ln x. And here negative ln x only remains, is equal to 1. Cancelled out. 1 is equal to 1 as the situation demands. We have met this equation. Questions demand as well, and we have proved yes, the opposite written functions are the solutions of these differential equations individually, as we have verified. Moving towards question number next. Again, same sort of question. We have given differential in that case, dy and dx. We are asked whether or not we are in a position to find its order and degree. Order and degree. Why not? We can. Like this, we manage the ratio dy over dx. Then we are in a position to tell the order and degree. Yes, we can. Question number 4. We are asked to find order and its degree. I think order and degree, if possible, for different. Even we can solve this. However, solution is not demanded, but we can solve this as well. Order and degree. What we have? Dy negative sine x times dx is equal to 0. That is the practice for upcoming exercise. Separable differential equations. Shift sine x dx on the right hand side. Dy, it is equal to sine x dx. Shift dx here. Dy over dx as the magic ratio. Differentiation, instantaneous rate of change. Dy over dx is equal to sine x. Its order is, how many times it has been differentiated? Only 1. So order is 1 because first derivative is present. Order is 1. What about degree? Overall power of that highest order derivative. For order 1, it has been differentiated 1 times, having overall power 1. Its degree is also 1. Its degree is also Degree is also, we have demanded the order and degree. Let's solve this equation as well. How we can solve? From here, dy, sorry, let me write dy is equal to sine x dx. Whenever you ask to find solve differential equation or area under the curve, these both are the questions of integration. Integrating both sides with respect to their independent variables, sine x dx. Differential of dy, integration of 1 dy is only y. Integration of sine is negative cos x plus e. That is the solution of that differential equation. That is the solution of this differential equation. We are asked only simply to find its order and degree. First, we have to convert this dy dx, the differentials, in that form, dy over dx. Then it has order 1 because it has been differentiated 1 times, having overall power 1, degree 1, order 1, degree 1. Okay, cool. Verify that the function, same question. In that case, y is given to us, differentiate 2 times, put here and verify both sides are equal. Here both sides are equal, or you can find the differential equation for this function itself. It must be like this. Let's see and find out. Okay, question number 5. Question number 5. Question number 5, that is y is equal to a cos x plus b sin x, and our differential equation demands double derivative. D square y dx square plus y is equal to 0. Okay, cool. Differentiating one time, dy over dx. These are the simple trigonometric functions. A differentiation of cos is negative sin x. Look at the angle. Angle is simple one. Differentiation of angle is 1. X differentiation of x is 1 plus b times differentiation of sin is only cos. Let us settle the dust. It can be written as negative a times sin x plus b times cos x. It's our first derivative. Again differentiating to get to second differentiation, double derivative. It can be written as d square y over dx square. Writing once more, a differentiation of sine is only cos, differentiation of cos is only negative sine. It will become minus plus minus, minus a cos x minus b sin x. Put both values here, you will get both sides equal. Here, let's see, d square y dx square plus y. Value of y is, okay, in next step I can, okay, value of double derivative is negative a cos x, negative b sin x, and value of y is a cos x plus b sin x. A cos x plus b sin x. A cos is cancelled. 0 is equal to 0. Yes, it is the solution. It is the verification that we have generated second derivative and we have inserted in this. From this function itself, we can generate the differential equation. How? Take minus common from here. A cos x plus b sin x. Look at this. It's again our value of y. Instead of a cos x plus b sin x, write y. And both the constants a and b has been eliminated in that case. Dy over dx square is equal to minus y. Minus a cos x plus b sin x is equal to y. It is given to us. Shift y on the right hand side. Left hand side, it is going to be our required differential equation where the constant has been eliminated. D square y, second derivative of y with respect to x plus y is equal to 0 as it is mentioned. It is verification. It is the accomplishment of the differential equation independently itself from the given function. What is our requirement? We have two constants. We have to eliminate these both constants. We can differentiate at most 2 times and utilizing the given value of y to arrive at the result. Okay, cool. Final question comprising 2 parts. For advanced differential equations, it's a good question. Otherwise, whatever it is, it is. Okay. Here we are asked y1 is equal to x square and y2 is equal to x cube are both the solutions of this differential equation. This one and this one. Let's take one by one both. We are verifying the number 1. y1 is equal to x square. How many times differentiation has been required? 2 times. So y1 differentiation 1 times differentiation of x square is 2x. The double derivative of y1 leads to 2. Leads to 2. Plug both these values here. Value of double derivative, single derivative, and y itself. Let's see what props up. X square y dash minus 4xy dash plus 6y is equal to 0. Here it's double derivative. Okay, x square y double dash means 2 minus 4x y dash means 2x plus 6y means y itself means y1 x square. X square. It is going to be 2x square 4 to the 8x square plus 6x square. Look at this 2 and 6 8 and it's negative 8. 8x square minus 8x square both cancel out. 0 is equal to 0. Yes, y1 is the solution of this differential equation. Let's check y2, that is x cube, another solution. Let me take y2 is equal to x cube, differentiating 2 times and putting the values. What is the result? Let's see and find out. y2 x cube, differentiating 1 times 3x square. Again differentiating this y2, y double dash 3 to the 6x, making power coefficient, dragging the power down, subtracting 1 from the power, utilizing this simple rule for differentiation, x raised n. Differentiation, let me write m because mine m and n are almost identical in writing. M times x raised m minus 1. That's a simple rule of differentiation. Okay. Single derivative, double derivative, it's y. Put again in the same differential equation x square y double dash minus 4x y dash plus 6y is equal to 0. Okay, cool. X square double derivative is equal to 6 times x minus 4x. Single derivative is given by 3x square plus 6. Y means x cube. Y means x cube. Okay, it will become 6x cube. 4 3 the 12x cube plus 6x cube. 6x cube, 6x cube, 12x cube. That's negative 12x cube. Cancelled out. Yes. Both y1 and y2 are the solutions of this one. Y1 and y2 are the solutions of this one. Now, we have given a constant C1 and C2 along with y1 x square and y2 x square. Now, taking both by C1 and C2, multiplying some scalars. Some scalars we have verified. These are the solutions of this one. Now, C1 y1 and C2 y2 are also solutions of this one. We have to check. Means we have C1 y1 means C1 y1 is given by x square. Differentiating 1 times, it is going to be differentiating 1 times. It is or C1 2x. Differentiating another times 2C1 2C1. Similarly, this one cy2 is equal to c2x cube. That's c2. Where it is? It is c2x cube. Differentiating 2 times 3x square 3c 3 times c2 x square first, then 6 times c2x is another solution. This is double derivative and this is single derivative. This is single derivative. Sorry, this is single derivative and this is double derivative. Single derivative and double derivative. Putting again in this, what we are going to have, let's see and find out. X2y double dash minus 4x y dash means first derivative 6 times y is equal to 0. Taking these two, we have x square, double derivative of this function, c1 times y1, that is 2c1 minus 4x. Y dash, single derivative, that is 2c1x. 2c1x plus 6, value of y is itself c1 x square. c1 x square. It will become 2c1 x square, 4 to the 8 c1 x square, that is 6c1 x square. This is 2 and this is 6. It will become 8 c1 x square minus 8 c2 c1, sorry, 2 and 6 8, and it is itself 8 c1. Cancelled out? Yes. Having a constant c1 or c2 makes no difference. I have verified this. Let's verify this one as well. Then moving to our superposition principle. It has been given to us indirectly. If y1 is the solution and y2 is the solution, their linear combination in any form is also a solution of the linear differential equation. It is known as superposition principle, as you learn in higher classes, not at your intermediate level. A differential equation may have more than one solution, as in this case, this one and this one is a solution. Multiplying any constant with these two solutions doesn't affect the validity of these functions to be the solution of this differential equation, as well as their sum principle of superposition states that it is also a solution of linear differential equation. It is also a solution of linear differential equation. Let me verify this C2 for you. What I have? X2 x square y double dash minus 4x y dash plus 6 times y is equal to 0. Let me take this one now. C2y2, it is equal to C2 x cube. First derivative, it will become 3c2 x square. Number one derivative. Another derivative, this is first derivative, this is second. 3 to the 6c2x. Plug in the values here. X square, double derivative of this one means 6 times c2x minus 4x. Single derivative means 3c2x square plus 6 times c2x cube, bracket close. It will become 6c2x cube. 4 3 the 12 c2x cube plus 6c2x cube. Look at this, positive 6 positives. It will become 12 c2x cube minus, that's also 12 c2x cube. Cancel out. Yeah, 0 is equal to 0. It's a solution. And this is known as superposition principle. It states that a linear equation has more than one solution. The linear combination of this one, y1 y2, y1 plus y2, or writing any coefficient here like c1 y1 plus c2 y2 is also a solution of this one, where c1 and c2 belongs to real numbers. Let's check this superposition principle. Now, taking both these solutions at a time and plugging in, it is also a solution of this one. Independently, y1 is a solution of this one, y2 is a solution of this one, as well as c1 times y1, c2 times y2 is also a solution of this one. They are linear combination. Their sum and difference is also a solution of this one. This principle is known as principle of superposition. Let's verify this one. Now, taking both y1 plus y2 as ry, it's equal to x square plus x cube. Differentiating one times, it is going to be 2x plus 3x square. Differentiating again, 2 plus 6x. Plug in the values here. X square, y double dash minus 4x, y dash plus 6y is equal to 0. Let's find out Let's verify principle of superposition. X square y2 means 2 plus 6x minus 4x. Y means double derivative. Single derivative means 2x plus 3x square. 2x plus 3x square plus 6. Y means x square plus x cube. It must be equal to 0. Multiply throughout 2x square plus 6x cube. It will become 4 to the 8 x square minus plus minus 4 to the 12 x cube here 6x square plus 6x cube. Look at the square terms 2 and 6 it will become 8 and negative 8. 2x square plus 6x square minus 8x square. Collecting the like terms, square terms having cube 6x cube plus 6x cube and this negative where it is negative 12x cube. Negative 12x cube. Now it will become 8x square minus 8x square 12x cube minus 12x cube cancelled out. Yes, we have verified the superposition principle. It is said that if y1 is the solution of the differential equation, y2 is another solution of differential equation, their linear combination in any form is also a solution of this one, provided that the equations are linear. It's my tiny effort to explain to you some tips about differential equation. It's all by itself.